All right, thank you very much. Today we want to talk about Kubernetes, but we also want to talk about VMs. So my name is Simon Krenger, I'm from Bern. With 3 minutes delay, we'll start. The Swiss person in me is getting a little bit nervous with this delay, but we'll make it go. Anyway, so we'll talk today about KubeVirt. So we want to see, okay, what is KubeVirt? What does it do well? What things does it not do well? And if you want to try it out, what should you pay attention to? So I promise this is the only analyst slide in this deck. So this is from IDC. They had a look at how workloads are deployed. So you can see in the last 10 years, many applications have been modernized. They've moved to containers, to Kubernetes, to Docker, whatever. And as a cloud native person, I like that. But we can still see that there are a lot of VMs still around. So I guess in many of the companies that you guys work at, the percentage of workload that has been containerized is maybe a bit higher. But for most of the companies that are here, we can see there's still a lot of VMs around. So still a lot of traditional workload. So especially in large companies, it's not unheard of that most of the workload is actually still running in VMs. So for us as cloud native people, this is great. So there is still lots of work to be done for us. So these VMs, they typically run in our traditional hypervisors. Most VM teams, they still operate by ClickOps, so clicking around in the UI. That's just the reality of things. But would it not be nice to also manage your VMs in a cloud-native way, via an API, or even better, the Kubernetes API? Or maybe also your CIO comes to you and tells you, hey, I got this really huge bill from my current hypervisor vendor, and you guys, you do Kubernetes, so can we not do VMs as well? And you will be like, not really, but I can check what we can do. And this is where KubeVirt comes in. So we want to run VMs in Kubernetes. So you ask, Simon, VM and Kubernetes, that doesn't go together. Kubernetes pods are not VMs. It's not how it works. And you'll be right. However, what we can see is that on my laptop, when I run a KVM virtual machine, all I see is a QEMU process, as you can see on the slides here as well. So a KVM VM shows up as a process in Linux. And so if I run this here on my laptop, we can see that the process running. So it's just a process. And this is what containers do, right? They isolate processes using kernel namespaces and C groups. So why not do that? And this is exactly what KubeVirt does, right? So KubeVirt provides a Kubernetes API so we can run our VMs within pods. KubeVirt is an open source project and a cloud native computing foundation incubating project. And we'll see all the individual technical parts afterwards. But KubeVirt allows us to run VMs with a Kubernetes API that we can use to manage our VMs. So basically, it's just an operator and a controller on Kubernetes. And then we can manage VMs by using custom resources. We'll also see that in the demo afterwards. So how does it technically work? As I said before, we just take our QEMU or KVM process that we're using to run our virtual machine, and we just pack that thing inside the pod. And we run it alongside our existing containers. So from a Kubernetes point of view, it's just another pod, just another process that we're managing. Now, well, given these VMs are rather large, right? These are big pods, of course, but still, it's a pod. Now, these VMs, they have a lot of state typically, so we'll have to also manage the state somehow. In practice, that's done by storing the image in a PV, so in a persistent volume, and then simply attach that to the pod, and then start your QEMU process with that. So when we then store this disk image on a PV, we can also use all the Kubernetes features, having read-write many, move VMs from one node to another, for example. So all these live migration things with VMs, we can do this without any interruption for that VM. We'll see that disk file in the demo later on. So let's have a closer look at what the components of KubeVirt are before we jump into this demo. So here is this slide with all the components, but we'll go through them one by one. So on the left side, we have our API server, and then on the right, there is an example of a node that we want to use to run our virtual machines. So let's start with the left side here, the API server. What are the API components? So there are different components here. So one is the controller for KubeVirt itself. It's basically the controller that works with all the custom resources and then changes the state accordingly. It manages the pods and works also with Kubernetes, with the Kubernetes API to really do what KubeVirt should do. And then, of course, we have the Virt API, which is just the API that the aggregated Kubernetes API that is being used to provide all these different KubeVirt APIs. We'll see the CRs later on. Then the more interesting part is on the actual nodes where we want to run virtual machines. So on the node, there also needs to be a pod deployed by a daemon set, which is called this Virt handler. And it manages all the things outside the VM. It doesn't manage the VM itself, but it manages all the things that need to happen on the node for a VM to start. So examples would be things about storage, things about networking. You can think of this one a bit. This is kind of the kubelet for the VMs that we're running. Then also on the node, we typically then have our VMs, of course. So for each VM, you would then see a separate pod. And this is something then will also see. It's called a Virt launcher, and it runs the QEMU process. So this is the process that will then containerize, and it will run. This pod has a local libvirtd instance, and so it has all the KVM stuff in there. It has all the C groups, of course, and the namespaces that are being used, just like a normal pod. And one important thing that is normal for normal container images, but not for VMs, is it also handles signals. So when we stop a pod, what should happen to it? Should the VM be terminated or not? Or should it be moved to another instance? Things like that are being handled by this, let's say, wrapper pod, right? Now, I talked a lot about QEMU. So we would think, oh, this sounds like emulation, right? So on an x86 machine, for example, if you run an x86 virtual machine, there is no emulation. The native virtualization features of your CPU are being used, but of course it can also emulate other architectures. What QEMU does, it emulates all the other hardware devices, such as disks or network interfaces, things like that. This is where QEMU is used. So there is no emulation per se, this is native virtualization. So now we've seen a lot of slides, right? So let's see how that looks in practice. So here on my system, I have, let me make it bigger. So this is my, it's a, what is it, Minikube? Yeah, it's a Minikube, or a kind this time. It's a kind cluster, and what we can see is when we get the pods on this cluster, it's a bit too big now, right? What you can see actually is that there are a lot of QEMU stuff is running, right? So we have the containerized data importer here. Then down here we have all the different components we just saw on the slide before, right? Here is our API that is providing the Kubernetes API. We have our Virt controller, which does all the things. And then this is the process that is running on the actual node. So when we have a look at the CRDs that are provided by QubeVirt, we can see there are a lot of things that are for VMs, right? So we have here, this is for data importing, this is for importing VM images. We have here virtual machine clones. So we see this is already starting to go into having a declarative mean to do something, right? So clone a VM, for example. We have then down here, you have the instances actually. We have the virtual machines themselves. We have restores, we have snapshots, all these different things. We try to put them into a declarative API. So having said that, we'll try to see, at the moment, there are absolutely no VMs in this environment. So let's see what we have. So here I have my YAML, right? We all love YAML very much. It's what Kubernetes does best. And so what you can see, it's a kind virtual machine, and it has all the things you would expect a VM to have, right? So here, if you go to the spec down here, we see, there are cores, there is memory, there is disk stuff here, there is a CD-ROM even, and so we saw all the VM things, but there are also cloud-native things in here, such as a readiness probe, and things like persistent volume claims, etc. And then we get again VM stuff. So here, this is a cloud init. I just set a password, put my SSH key in there. So the point is that this YAML, it tries to describe the VM in a declarative way via the Kubernetes API. So this is exactly what you would expect here, right? So if we apply this file, we can then have a look at it, and it will tell us, yeah, okay, I've created it as you would expect, but it is stopped at the moment. Of course, I could now go into the YAML, edit this object, etc., and just change it to running, and then the VM would actually run. There is also this KubeVirt CLI, which is called virtctl, and you can use it to interact with your VMs that are running in your Kubernetes cluster, and this will basically go to the Kubernetes API and do this change to running, etc. So it helps you a bit with managing your VMs, basically. Anyway, so I've started my VM, right? So if I have a look now, it's running. Nice. So this is what we expected. It's not yet ready. My readiness probe is, I think it's on the SSH port. I check if it's available. And I can also have a look at the pod that is now running. So this is not the VM, right? So I see the VM, but I see it has this Virt launcher pod, and it has this Simon's Fedora VM with it. It is running, and interestingly, we will also see the IP that is assigned to this VM. So if we have a look, now it's even ready, right? So we can see it has been started 57 seconds ago. It has an IP, so all is fine. This is very nice. So now I can also do, of course, what you would expect with a VM. I can also go into it, right? So here I'm now in this VM. Let me log in with my very secure password, test123. Very good. So we can see it is up since 1 minute. And what else can we see? We uname -a. Anyway, it's a VM. This is more expected. What we can also see, and what is very interesting, is that we have, of course, we have an IP address, and this is, of course, from the pod network. So this is the same IP that we see for the pod is also assigned to the VM itself, and we have it here. So this worked quite well. Thank you very much. So let me exit this. This is a bit of a thing. So now we can see this is all running. And when we have a closer look at it, so I'll export the name of the pod here, and then let's see inside of this pod, this Virt launcher pod. I mentioned there's a KVM environment in there. So when I do virt list, I can inside the pod, I will see there is a KVM VM running in there. So I can use all my the well-known which commands that there are. I can have a look at all the interfaces, for example. You see there's a MAC address and everything. So within that pod, I have a full KVM environment. I can do all the things I can do outside with my normal KVM installation. And it's basically just wrapping this, putting this into a pod, and providing a Kubernetes API for it. So this is quite straightforward. Before, we also talked about how data is managed, or state. So VMs, they have a disk, right? And there things are happening with the VM. And in this case, on my client cluster, it is a persistent volume that is mounted to the pod. And within that persistent volume, we have a disk image. This is it. And then this KVM process is started with this disk image, and then we can go from there. So we can see that we have here a disk image. You can also have it with a persistent volume with block storage, for example, and then you could just directly mount this to your KVM process, and then you would have a native storage for your VM. Good. So that was the demo. That went surprisingly well. Next up, we would like to talk. So we saw the demo that worked. What I really like about KubeVirt is it allows us to manage our VMs like we would manage pods. And for us cloud native people, there are some obvious things that you can do that for VM people are absolutely mind-blowing. Things like GitOps, right? You can manage your VMs with GitOps. For many VM people, this is just black magic, you know. But for us, it's a very nice way to interact, define, change our VMs and how we work with them, right? So managing VMs with GitOps is really, really awesome. So compared to having ClickOps before with the UI and everything, now we have an actual proper API that we can use, and having that is really, really nice. So not only can we easily interact with it via the Kubernetes API, of course, Kubernetes brings you so much stuff with all the failover things and the readiness probes and all these cloud native concepts that we take for granted that we can now use for VMs, you know, for free, basically. So this, for example, this automatic reconciliation that you can use when there is a disruption, Kubernetes will take care of it, restart stuff, self-heal stuff, really good. So it's really nice to have all these Kubernetes features. Then QEMU and KVM, these projects have been around for a very long time. These things are quite rock solid. They work well. Let's put it this way. So the KVM part really works well. What is still growing and still changing a lot is, of course, the KubeVirt stuff. But the underlying technology of KVM and QEMU, this one works well. Now, of course, so this is the green slide. So you know what comes next. It's the orange slide. And the orange slide is about what does not work, right? So we're mixing concepts of having cloud native workload and this, let's say, old school VM workloads, and we're mixing it up, and things sometimes don't work as well as we would like. Now, as it says on the slide, the biggest challenge of all is getting the VM people to accept this. They will not. So with VMs and Kubernetes, there is a large gap in mindset, right, between the cloud native people who are maybe in this room with us today here and how, you know, the traditional IT works. So getting these virtualization teams to embrace Kubernetes, to embrace an API-centric way of working with your cluster is really, really hard. So people that spent the last 10 years working with cloud native technologies, for us, some of these things are just, you know, obvious, but getting other people to understand this is really the biggest challenge of them all. Now, this is a people problem. There are also some technical issues. So there is a significant difference in how traditional hypervisors and Kubernetes use, for example, things like storage. So with Kubernetes, what happens is your PVs or your volumes, they're often moved from one node to another, right? This is what we do every day. But the storage systems used for hypervisors are often very static. There's no change at all. So, right, you provision it at one point and then it doesn't change for 10 years. And depending on, you would be surprised how many storage drivers, CSI drivers for, let's say, traditional storage boxes does not work well with this whole dynamic thing of, okay, now we move this PV to this node and that, and all this CSI drivers are a big challenge. So depending on what CSI driver you use, you might have a bit of issue with this whole storage. So this is one thing we see. And the next you saw already in the demo. What we get in our VM is by default is an IP from the pod network. So how useful is that? It's not very useful, is it? Because you cannot SSH into it unless you make a service somehow and expose it via another route. So it will also, your usage of KubeVirt will strongly depend on what your CNI can do. So not only CSI, which is the first part, the CNI, your network, will need to support this, that there are VMs which you maybe would like to access directly and not via an ingress or a service or whatever. Maybe you also have special routing, BGP, VLANs, all these different things, and your CNI needs to do this then. And there are some CNIs that can do it very well, but others, they cannot. So you will only get your VM, will only get a pod IP, but this is not very useful typically. Then lastly, this goes a bit into the same direction we had with the mindset before about how there are differences, how you would operate a VM versus how you would operate a pod. So a good example is, okay, you go into your VM, let's say your Windows VM or whatever, and you shut it down. What do you expect to happen? It should shut down, right? Well, so in KubeVirt, you said, oh, this VM, it needs to be running, right? It's declarative, so it still says it needs to be running. So what will it do? It will restart the VM because it's a declarative system. Kubernetes will see the VM is stopped. I need to start it. So this is unexpected, right? Another example is readiness probe, which is a nice concept in the cloud-native world. Now, in my demo, I had a readiness probe on my SSH port. But what happens now if I want to reconfigure my SSH daemon, I stop it, I stop the service, my pod will get restarted, or my VM will get restarted. Not exactly what you would expect, right? So there are some clashes between how VMs operate and how Kubernetes pods operate. So this is a bit of a challenge. It takes some getting used to. You might need to address some of these in a technical terms. Okay, so we talked about what works well, what does not work well. There are some challenges around. So how can we actually use this? So what we've seen is that there are generally two strategies for using KubeVirt. So the first one is, okay, you want to modernize your application, and what you can do is you can use KubeVirt to move your existing VM workload closer to your containerized workload. So you have maybe an application that you want to modernize. Some part of it is already in Kubernetes, some is still in VMs, and you want to manage these VMs the same way you manage the pods. So KubeVirt can be a great way to move these VMs into your Kubernetes cluster and manage them the same way using GitOps, all of these kind of concepts. And this is really, really nice to help you modernize applications. And then, of course, getting to replace your existing hypervisors, you can have Kubernetes cluster to really run all your VMs and then change how you operate your VMs and really embrace KubeVirt to run your applications. What works really well is all these let's say, legacy applications that still run in a VM. So we say a lot of Java processes, Windows applications, your application servers. This works well. What does not work well, or where we as consultants tend to say, oh, it depends. If you have VMs with special requirements, for example, real-time kernels or special hardware, things like that, you would need to evaluate that. Also, everything that is that needs all the hardware to function, think all the Windows XP, legacy VMs, the Windows 2003 servers, all the Unixes, they might need an old chipset. And while QEMU can do this, we've seen more problems with it. So having the modern stuff works well, the legacy stuff, it depends. Then this is not a technical issue, but more of a, let's say, licensing or support by vendors, things like Oracle databases, SAP. This is not certified to run on KubeVirt, so maybe this is not something you would want. Good. So just to repeat a few key points. So KubeVirt is a great solution if you want to run your VMs in a cloud-native way. If you want to run your VMs by talking to a Kubernetes API, if you want to use GitOps also for your VMs, and if you want to modernize your applications and you want to move in closer a bit, you want these VMs that you still have, but you want to modernize them at some point, move them a bit closer to your containerized workload. This is what KubeVirt excels at. A good implementation depends heavily on your CSI driver. So what can your storage do? How well does it work with Kubernetes? Then how your CNI works. So can it do all the things you need to do with your VMs? Can it do PGP, VLANs, all these crazy things? Can it do that or can it not? And then lastly, so as you maybe saw or heard, so managing VMs via Kubernetes API and via GitOps is really, really awesome. With that, I'm at the end of my talk. Thank you very much. Maybe we'll have time for questions, maybe not. Thank you very much.
Amazing, thank you. So I think we have time for 2 or 3 more questions. We have a volunteer with a mic over there. We have goodies, we have Haribos, so feel free to ask questions and earn a gummy bear. Yes, we have first question over there.
Thank you for the talk. First question would be, what CNI would you recommend? And my second question would be, does it support live migration and how good does it work?
So I'll address your second question first. So the live migration, as we saw, what you just basically need is a storage that has read-write many. So what happens is there are 2 pods being started, right? That have the KVM process running with this PV attached. Then you start a second pod, and at some point it's cut over. This works quite well. So this whole live migration, this works quite well. Now, the first question was about the CNI that I would recommend. So as a Red Hatter, of course, I would say yeah, OpenShift does it really well, right? No, but there are others, such as, for example, Cilium has a lot of features, but I don't know a lot of others, to be honest. So you would need to look into your actual CNI to see if it supports what you need to do. I know that OVN Kubernetes, that is being used by OpenShift, can do lots of these features, and I know that Cilium can do some of them. For others, I'm not sure. But thank you for your question.
All right, so one more possible question. Anybody? Cool. Yes, question over there.
Yeah. You were talking at the beginning about the big bill, right? And my question is how or what the impact it does have, this approach. Like, can you tell some real world numbers?
So I don't have these details. I'm a technical guy. I'm not a sales guy. So our salespeople, of course, the Red Hat salespeople, they have all these conversations with customers that get a big bill. and then they come to us screaming and saying, "Oh, we need a solution." So I don't have this information. But maybe we can talk afterwards, and then we can have a look at your question more closely.
Great. Thank you.
Thank you very much.
Right. Thanks for the talk. Thanks for the questions.